Before entering the plant, all personnel must wear proper personal protective equipment or PPE. Safety goggles protect the eyes from chemical splashes. Gloves protect the hands from heat and hazardous materials. Coveralls fully protect clothing and skin from spills and contact with chemicals. Closed-toe shoes safeguard feet from heavy objects and spills, while hard hats prevent head injuries from overhead hazards. In areas with loud equipment, hearing protection is essential. Proper PPE makes sure both safety and efficient operation in the plant. Before starting any operation, all personnel must attend a safety brief. Everyone must follow standard operating procedures, be aware of chemical hazards such as methanol and catalysts, and stay within designated work areas. Eating, drinking, or using phones in the production area is strictly prohibited. Any spills, leaks, or unsafe conditions must be reported immediately. Finally, everyone should know the location of emergency exits and safety equipment, including fire extinguishers and first aid kits. Safety briefings make sure a safe and efficient working environment for all.
The utility departments provide essential support for the plant. Steam is generated by the boiler, excess heat is removed by the cooling tower, and compressed air, power valve, and instrument. This system ensures the process plant operate efficiently and safely. The process plant is where biodiesel is produced. Raw oil is transferred into reactors, mixed with methanol and catalysts, and heat to trigger the trans-esterification reaction. After the reaction, biodiesel is separated from glycerol, and continuous circulation ensures uniform quality. The control room monitors all plant operations in real time. Operators track temperature, flow, and pressure using SCADA system. Immediate response to alarm and irregularities maintain safety and optimize production.
Now we demonstrate the startup of the cooling tower in the utility department. First, check the water levels in the tower to ensure adequate supply. Verify that all valves and pumps are in their correct positions. Start the circulation pump to begin water flow to the systems. Ensure the cooling tower fans are operating correctly. Finally, monitor temperature and flow to confirm the system is functioning efficiently and safely. Now we will demonstrate the startup procedure for the boiler in the utility department. Safety and accuracy are essential in every step. First, check the water level inside the boiler carefully, or the sight glasses outside of the boiler box. Maintaining the correct water level is critical to prevent damage and make sure safe operation. Next, inspect all safety valve, pressure gauge, and temperature indicators to confirm they are functioning properly. Verify that the fuel supply, whether gas, diesel, or another energy sources, is secure and ready. Begin the ignition sequence to start the boiler. Once the boiler ignites, monitor the pressure and temperature closely, making sure the readings remain within safe operational limits. And finally, ensure that the system output is stable and consistent before the system is considered fully operational. This step is vital because a properly running boiler provides the necessary steam for heating, process operations, and maintaining overall plant efficiency. Next, we demonstrate the procedure for transferring steam from the steam header to the plant at a pressure and about 8 bar in boiler area. Firstly, open the isolation valve, connecting the steam header to the plant distribution system. Confirm that all valves are in the correct position to prevent leakage or backflow. Verify that the steam pressure is at 8 bar before starting the transfer. This will make sure that the equipment receives consistent and sufficient steam for heating and other operations. Start the steam distribution pumps to circulate steam to the plant equipment. While the steam is flowing, carefully monitor flow rate, temperature and pressure to ensure they remain within safe and operational limits. Once the system is stable, the plant equipment receives the required steam at 4 bar, ready for operation. After we already done with the two station, which is cooling tower and the boiler, so we will go through with demonstration the startup of the compressed air system in the utility department. Compressed air is essential for operating valves, instruments and other plant equipment. Begin by checking the oil and coolant levels in the compressor to ensure safe operation. Inspect the inlet and outlet valves and confirm they are in the correct positions. Verify that all electrical connections and safety interlocks are in places. Start the compressor and allow it to reach operating speed. While the compressor runs, monitor pressure, temperature and vibration to ensure the systems operate smoothly. And finally, confirm that airflow to the plant equipment is stable and meets operational requirements.
Now we move to the process plant, where steam from the heater enters the plant to provide heating. Follow the pipeline as it traces towards vessel 202, ensuring all isolation valves along the line are open and operating correctly. Steam enter vessel 202 at 4 bar, providing the heat required for the reaction process. Monitor the pressure and flow at the vessel entry to ensure safe and stable operation. Keep an eye on the vessel temperature and liquid level, as these are critical for maintaining the reaction condition and overall process efficiency. Before starting the steam supply to process plant, the plant team must coordinate with the control room. Permission is obtained to set the steam pressure at 8 bar, ensuring safe operation. Once authorization is given, the isolation valve along the steam line are open to allow steam into the plant. The team then carefully monitors the steam flow and observe vessel 202 temperature and level to maintain proper reaction condition. Coordination with the control room is essential to ensure that pressure, flow and temperature are stable, preventing unsafe conditions and ensuring efficient plant operation. In this stage, we focus on preparing vessel 202 for the reaction by carefully controlling the airflow, steam supply and vessel temperature. First, AV222 is open to provide proper ventilation. This valve allows air circulation within the vessel area, preventing pressure build-up and ensuring a safe working environment. Ventilation is essential to maintain stable operating conditions and protect both the equipment and personnel. Next, AV229 is open to allow steam at 4 bar to enter vessel 202. This steam provides the necessary heat to achieve the correct reaction temperature for biodiesel production. The pressure is controlled to ensure the vessel receives the right amount of energy without exceeding safe limits. After steam flow is established, TV202 is open to regulate the vessel temperature. This valve ensures that the reaction is maintained at the target temperature, avoiding overheating or underheating, which could affect both reaction efficiency and biodiesel quality. Throughout this procedure, operators monitor the vessel condition, including pressure, temperature, and liquid levels, to confirm the system is stable. Proper operation of this valve is critical for both safety and process efficiency, ensuring that vessel 202 is ready for controlled chemical conversion while protecting personnel and equipment. After the valves are set, the mixture in the vessel is circulated. Running the mixture allows heat to ascend evenly throughout the vessel. preventing hotspot and ensuring uniform reaction condition. Continuous monitoring of temperature, pressure, and liquid level is essential to maintain both safety and reaction efficiency.
Now we are in the control room, monitoring the heating process for vessel 202. All steam entering the plant from the header is traced to the control room system to ensure it reaches the vessel safely and at the correct pressure. Operators verify the status of all relevant valves, which is AV222 for ventilations, AV229 for 4-bar steam input, and TV202 for temperature regulations. Each valve's position and flow readings are displayed on the SCADA system for the real-time monitoring. The control room also tracks the circulations of the mixture inside vessel 202, confirming that heat is ascending evenly throughout the vessel. Continuous monitoring of temperature, pressure, and liquid level ensure the reactions proceed safely and efficiently. Any deviations are immediately flagged for corrective action. While the plant is operating, control room personnel continuously monitor all instruments on the PC. This includes tracking steam pressure, valve position, and the temperature of vessel 202. Any changes in mixture circulation, heating, or flow rates are carefully observed and recorded. All observations are documented in the logbook with the corresponding time, ensuring a detailed record of plant activity. Effective communication is essential for safe and coordinated operation across all plant areas. Operators use walkie-talkies to coordinate utility, process plant, and control room activities.